right, everybody, I've never actually tried teaching like this, so this is gonna be my first time. We're gonna give it a shot. So I already have the notes here written down for you in our class notebook. This video is me explaining those notes. So if you felt like you wrote these down and you did not get it at all, this is the thing you should watch to make sure you do get it. So let's work this through step by step. First of all, synthesis. What does that word actually mean? Synthesis as a word means to combine or create. So if I synthesize something, that means I created it. If I might synthesize an argument, or I might synthesize a new chemical that solves acne. Synthesis means to combine or create. So the reactions we're talking about are going to involve combining stuff or adding stuff together to create something larger or bigger. Kind of similar to, what was that one? Fusion, similar to fusion. Now, the word synthesis here, I want to point out, this is just one of 5 types of reactions that we're going to be talking about. So the lab that you did last week, the lab that involved like the smoke and the smelliness, all that stuff, that was a synthesis reaction. We saw iron and sulfur combine to create iron sulfide. That general form, that general equation, combining stuff to make a bigger thing, that is synthesis. That's what we define it as, okay? So when we represent equations, we have a couple different ways. We've already seen like sentences and symbol, but for the 5 types of equations, because there are 5, each one has what's called a general form. What that looks like is here. We say A plus B creates AB, something bigger. So this A and B could be anything. It could be iron, it could be sulfur, it could be carbon dioxide, it could be water. But the point here is that we're taking 2 things and we're combining them to make a bigger thing. So that general form, we're going to keep seeing it with each type of reaction we talk about. Again, this is one of them. We have 4 more after this. Here we have a couple examples of what synthesis reactions might look like. They don't look different than other things. However, sometimes they require heat in order for them to actually occur. For example, we had to heat up this iron and sulfur mixture to force those 2 things to combine. But some things happen naturally. If you haven't paused the video and do this demonstration over by the mirror on this side of the room, I don't know if you can see, but over here by the mirror where y'all check your makeup, go over there and try out this demonstration and try out the one further down. This will give you an opportunity to see more synthesis reactions in action and get an idea of combining 2 things to create a larger thing. Now for each type of chemical reaction, we not only need to be able to write the reactants and the right symbols and the right formulas, all that good stuff, but we also need to be able to predict the products. Just because we're starting with iron and sulfur doesn't mean that I'm gonna tell you what that becomes. Same thing with the magnesium and the oxygen you just saw in that demonstration. Just because we started with magnesium and oxygen doesn't mean we immediately know what that white powder is that's left over at the bottom. Part of chemistry is being able to make predictions based on what you know. So for all 5 chemical reactions we're gonna cover, we have to be able to predict the products of those reactions. For some of them, it's super duper easy, especially with synthesis. You will use the crisscross method to find the products when our reactants are a metal and a non-metal. That part's kind of easy. So iron and sulfur make iron sulfide. We've done that since last unit. Magnesium and oxygen will make magnesium oxide. Again, anytime we have metals with nonmetals, you just have to find that ionic formula for when they do come together. But that last one, it's a little bit trickier. When we have carbon dioxide forming with water, it's hard to predict that product because this is not an ionic compound. If we look at those reactants, not a metal, not a metal, not a metal, not a metal. This is all covalent compounds, so the product is going to be covalent as well. When we have covalent equations, we talked about how we have to be so specific with that naming. We have to use tri, di, hepta, hexa. We have to be so specific because covalent compounds can be any number of those elements bonded together. Remember, ionic compounds, it was very, very specifically, the charges have to cancel out. But with covalent, I could have 1,000,000 carbon and 1,000,000 hydrogen, and I could still make a functional molecule. So this gets really tricky. There is no way for us to predict the products of a covalent reaction, a covalent synthesis reaction. You don't know how. And that's not something you'll learn until you take like OChem. And even then, still probably don't know. It's a little bit complicated. With that in mind, these are the skills you need in order to understand synthesis reactions. And like I said many times, this is one of 5 we still have to cover. You will be doing a lot more labs, at least 4 more. And what's important is that you get the hang of what will be expected of you. So first of all, that general form, I'm gonna scroll up here real quick. That general form, A plus B makes a bigger thing. You'll need to be able to differentiate between those 5 types of equations later on. Make sure you're getting the hang of seeing this form or getting the hang of identifying what that word synthesis actually means. Second thing, make sure that you understand how to find those products. That's going to be the expectation for all of these chemical reactions, all these chemical equations. And then last thing, if you were feeling kind of rough about making those equations, definitely start practicing more. Review what you've already written and make sure you understand the vocabulary going into that. What are reactants? What are products? What's a yield sign? How do we separate things? How do we name things? All of that is going to continue being asked of you as we move on. So with that, I've covered these notes. You should be good to move on.